This is a review for PC number 1 with semester 2. We're starting back at the beginning. There are 3 things we're doing mathematically. Number 1, converting standard form to slope-intercept form. Number 2, graphing slope-intercept. And 3, graphing implicitly from standard form. So first off, what are these different forms and what do they look like? This is slope-intercept form. It might look like y is equal to 3x plus 7. The general form, we use letters instead of numbers, y is equal to mx plus b. Why is it called slope-intercept? Because m is your slope, or in this case 3 would be your slope, and b, or 7, is your y-intercept. This quickly allows you to graph something with this knowledge. Standard form looks different. Instead of y being all by itself, x and y are on the left, and the constant is on the right. The general form, ax plus by is equal to c, and we plug in numbers like 4 for a, or 2 for b, or 8 for c. The first thing we did this week was start with an equation in standard form. Notice something x plus something y is equal to a number. And there were 2 steps. We moved the x, and we divided by our y. So for this problem, I subtract 3x from both sides, which allows me to cancel out my x term on the left. And if I carry everything down, I get y is equal to 8 minus 3x. Remember, because 8 is a number and x is a variable that cannot be combined. And we often rewrote this as negative 3x plus 8 instead. That's simply a matter of slope-intercept form, y equals mx plus b, the x term comes first. But it's identical, just changes the order. In this case, there's nothing to divide by if we look at y, because y's coefficient is an invisible 1. So if we divided everything by 1, nothing would change. For the second problem, the steps remain the same. Move x and divide by y. So the first thing we're going to do is subtract 4x from both sides. And I'll write this as 2y is equal to negative 4x plus 18. So I change the order. Instead of 18 minus 4x, it's minus 4x plus 18. And the last step, this time I can do it, is to divide by y. What's in front of y? A 2. When you divide every single term, not just once on the left and once on the right. This gives me y is equal to negative 2x plus 9. And now I'm in slope-intercept form because it looks like y equals mx plus b, instead of something x plus something y equals a number. Let's look to the homework to see other potential types of problems. The 2 steps remain the same. Move x and divide by y. So this time, to move x, I'm going to add it to both sides. And when I do so, it cancels out on the left. So I can rewrite this as negative 2y is equal to 7x plus 18. And my final step is to divide by whatever's in front of y, which includes the negative. And I divide each term. So I end up with y is equal to negative 7 halves x minus 9. A couple things going on here. When we can simplify and get a whole number answer, we do. 18 divided by negative 2 gives us a whole number. So the fraction is gone. We also notice that the negative that was associated with the 2 floats its way to the top of the fraction. So it becomes negative 7 halves x. And the reason why we keep this as a fraction is because negative 7 divided by 2 does not come out even. It would be a decimal. So I would recommend leaving those as a fraction. And now we are in y equals mx plus b form, which is slope-intercept. And we have left our original form, standard form, which was ax plus by is equal to c. Then on Tuesday, we started the same. We converted standard form into slope-intercept by moving x to the right and dividing by y. But then we graphed it. Let me show you how that works. So step 1 is to move the x. I'm going to do that by subtracting 3x from both sides. We end up with y is equal to negative 3x minus 3. On the right, I would take minus 7x and I'm left with 2y is equal to negative 7x minus 10. I'm going to divide everything by 2, and my final equation is y is equal to negative 7 halves x minus 5. Things to note, I did not divide by y in this problem on the left because y didn't have a coefficient. I wrote the x term, then the number, so instead of negative 3 minus 3x, I put the x first. When things came out as a whole number, like negative 10 divided by 2, I left it as negative 5. But when my fractions created decimals, I left it as a fraction. And remember, negative divided by positive turns out negative. It's only when you have two negatives that it comes out positive. To graph these, I'm going to begin with my y-intercept. That's this value right here, negative 3, or this value, negative 5. And this is where the line crosses the y-axis. So, on the left here, I will count down 3 and put a dot. And on the right, I will count down 5 and put a dot. That's the y-intercept. That's the easy part. Next up is the slope. Here I have a slope of negative 3. And on the right, I have a slope of negative 7 over 2. So when I have a whole number like negative 3, I can think of this as negative 3 over 1, because any whole number can be turned into a fraction by dividing it by 1. Then we consider slope as rise over run. How do I rise a negative 3? Well, that's like going down 3. So I would go down 1, 2, and off the graph here to 3, and I run 1. And that's where my second dot would go. If you want to avoid running off the graph, instead of thinking of this as down 3 and right 1, we can flip those and make it up 3 and left 1. As long as we change both, it still works. For example, I go up 3 and left 1. These are all points on my line. Draw a line through it, put your arrows, you're done. So the problem on the right, my slope is negative 7 halves. This is like going down 7 and right 2. Because slope is rise over run. And because the top part is negative, that means I go down, not up. If you look at this, it's not going to fit on the graph. If I try to go down 7 and right 2, I'm going to be way down at the bottom. So we might want to switch them and instead go up 7 and left 2. If I do so, I go up 7, left 2, and here's my other dot. Draw a line between the two, put some arrows, and you're done. For Wednesday's assignment, we plugged in zeros for x or for y to figure out the intercepts, and we call this graphing implicitly. So if x is equal to 0, we're going to get a certain result. I'll draw a line down the middle. And if y is equal to 0, we're going to get another result. This is important because to be on the x or y axis, x or y have to be 0. So for example, 2 times 0 plus 3y is equal to 6. I replaced x with a 0, which is the same thing as 3y equals 6, because 2 times 0 is 0. I can either say 3 times what is 6, or I can divide both sides by 3. Either case, y is equal to 2. And if x is 0 and y is 2, I can create a coordinate, 0, 2. If I was to graph it, here it is. I don't go left or right at all, and I go up 2. Now let's try plugging in a 0 for y. 2x plus 3 times 0 is equal to 6. So that's just 2x equals 6. And if I divide both sides by 2, I get x is equal to 3. And from this x and y value, I have another coordinate, 3, 0. So I count over 3, put a dot, and I'm good to go. Draw a line, put some arrows. I have graphed this implicitly. A faster way of doing the same thing is to say if 3x is equal to 15, in other words, ignoring the y for a minute, then I know that x is equal to 5, because 5 times 3 is 15. So on my x-axis here, I'm going to put a dot on 5. Then I'll go back to the original problem and say 5y is equal to 15. So what's y? Y is 3. So on my y-axis, I'm going to put a dot on 3. Simple?